Now we got it. I always forget to press the record button. All right, so welcome everybody. Welcome to our September meeting. This is our Homebrew contest, our annual contest, so we can all show some projects we've been working on. And we've got some prizes for top 2 and for rookie entry as well. So before we get to that, we'll just do the club business, and we'll just cover.
This is Phil.
Hey Phil, we can hear you. Oh, sorry, you're on the phone.
What's cooking?
All right. Maybe we'll wait until Phil's done and get on to Carol.
I just had a call on this
website update?
phone, and I was returning the call.
Let's mute Carol. There we go. Carol, do you have an update on our club website this month?
Sure, I can go ahead and share my screen.
Yep. Let me,
Okay, let me try this.
Yep, there you
go. See, are you seeing my screen here?
Yep, yes, you can see. Yes.
Okay, the website report for our website, which is n6na.org. And let's see if, oh, there we go. That's a screenshot of our website, and all of the information is kept up to date on our website there, of course. We have our calendar, announcements for the upcoming meetings, etc. And we recommend anybody who wants to find information about the club first to go to our website, n6na.org. And the website activity for the month of August, we had a little bit of a decrease in activity. We had a total a drop, but we had 1,678 page views in August, which over 28 days averages about 59.9 per day. The most active web pages were the home page, 454 page views. Then our 10-meter page, which was 290 page views, and a magnetic loop antenna project page, which was 157 page views. Most of our hits to the website were referred by Google, 55.3%, and 31.2% came directly to our URL, n6na.org. And the rest came through other services, referrals. And by region, 998 of the hits were from California, 63 from Oregon, 44 from Washington State, and the rest were from other states and countries, as you can see on the map. We have visitors from all over the world. And our social media, YouTube channel had 704 views. We have a total of 246 subscribers there now. And our Facebook page has 384 followers, and we have 137 followers on our Twitter page. And again, just a reminder, our URL is n6na.org. And if you have any wish to contact us at all, please send an email to contact@n6na.org. And that's it from here. So I'll turn it back to Kevin.
Thanks, Carol. Phil, are you off of the phone? I think we muted you because your phone was ringing. Unmute.
What would you like first?
Can we do Treasury update?
Okay, Treasury update. Let me turn this light around so I can see what I'm looking at when we get washed out here. At this point, our balance is $8,599.62. And about the only thing notable about last month is we had a couple of expenses against the repeater, one of which was some new feed line for a new voting receiver that's going up in El Dorado Hills. And then there was a donation to Chris Huber's repeater site that suffered a lot of fire damage. So repeater's expense this month was $877.49. Any questions regarding the P&L, profit and loss?
Sounds good.
No, we're good with that?
Yep.
Okay, let's move on to membership. As it stands right now, we have 142 paid members. We have 163 potential paid members, so we're running about 87%. And of those members, we're right at 60% of them are ARRL members. Those are the numbers.
A question, Phil. How bad was the damage to the repeater site there, Chris?
The repeater site we're talking about is Mount Vaca.
Yeah.
Mount Vaca had that fire blow right through the top of that hill. It took out the electrical service. It also destroyed about 20 different hard line feeders to the antenna structure, and it damaged a number of the antennas. We have a voter receiver up on that mountain, and Chris Huber's got his N6ICW main site on that mountain. So it took N6ICW out and it wiped out our second voter receiver.
Is there any insurance that'll cover that?
I have no idea. We have no ownership on that site. As I said, we had some equipment at that site, and our equipment was not damaged. The only thing that was damaged, of course, are the antenna for the receiver, which I don't think is much of an issue. But the electrical service is completely down, and all of the poles that lead up to that mountain are gone. PG&E's got quite a task on their hands to put power back on that mountain.
Chris is on. Chris, have you got any other news you want to share about what's going on over there?
Can you hear me okay?
Yeah.
Yes.
Oh, okay. Just didn't know the mic was up. Phil covered most of it. 50% of the PG&E poles in the immediate vicinity are down or have some damage, but they have a major rebuild. It may be back up with power for PG&E in a couple of weeks. They have an army of folks out there. They're working primarily down on Pleasant Valley Road where the residences are. And of course, that's where the power to the mountain comes from. So they're working their way up the mountain. And a lot of it's tough terrain. It's almost 3,000 feet they have to get up to. As Phil mentioned on the repeater site, the building that the equipment is housed in, it was one of the first ones. It's a cinder block building built back in 1955, and this is the third fire it's been through. It's the external stuff that gets beaten up real badly. Now, there's 30 radio sites over 2 miles over Mount Vaca, and there were a couple buildings lost, but mostly external towers and power issues along the ridge. And some sites survived. The fire was just really wild. There is a video running around, if you can get to see it, of the one of the radio sites on the north end, about a mile north of where I am, and the fire came from the north. So this was from lightning that occurred, and there was like 7 or 8 strikes occurred 2 days earlier approximately, and then they had these flare-ups, and it came from the north going southbound from the Napa County line. The ridge of Mount Vaca borders Solano County and Napa. And so we sit right on this rim that drops into Napa County. It drops off rapidly, and the fire swept up that, shooting flames up right over this building. Basically, the backside of the building looks like a blowtorch hit it. The site just south of us, 100-foot tower, antennas were melted at the 100-foot level. Back to this video that's running around, it actually shows a gentleman. That evening, there was power outages that PG&E had done for the heat wave. And they had the power down for the stage 3 heat wave. And it came back up at 9 o'clock Monday evening. And then about 11 o'clock, this radio site was anticipating that they were going to go back down again, possibly because of the fire. And sent a ham, who works for this two-way radio company out of Davis, up there at 11 o'clock at night. And you see him pull into the yard, and then like 15 minutes later, he's rushing out as he realizes flames are coming in behind him, and he boogies southbound to get off that mountaintop with flames chasing him. So it's quite incredible to see the firestorm. Anyway, the club's receiver actually is back up on VACA at a different site with power. I put one of my voting receivers back up, but my transmitter's down and I'm operating on an auxiliary site over in Bald Mountain in Yolo County. So I have no Bay Area coverage on my system. So with the redundancy, the site that I'm at is shared by 5 ham groups. We're splitting lots of these expenses and manpower. Next step is Thursday. We're meeting with a structural engineer who's volunteered his time to come up and inspect the tower and guide wires to make sure it's safe for us to work on. And also Jason from KF6 QXX has volunteered to do the electrical work, and he's replacing the service at his cost and taking out the permit. I was on the phone with Jason and the county for 3 hours this afternoon, and the county hazmat group to get a permit rolling, and Jason might have that together tomorrow. So busy time. Anyway, that's about all I have to report. I'm going to have a sip of water, and my t-shirt says it all.
Chris, this is David. How close are you to the PG&E site?
We're the next site south of that, so we're looking right over at them.
So they must have got hit pretty good.
No, actually they didn't. Again, it's the way the firestorm moved along the ridge and whatever protection you had. We had the brush cut back quite a bit, but we couldn't do the downhill slope, and that's where the flames shot up and just rolled over the top of the ridge. Then went eastward down the ridge towards Pleasant Valley Road. Usually fires are always going up the ridge. Well, went up and over and headed towards Vacaville, and they stopped it at Pleasant Valley Road, and it went south all the way to Interstate 80 where they stopped it there. So quite an incredible process, and they're still fighting it. It's up towards Berryessa now. Highway 20 and 16, I think, is where they're trying to stop it. I think it's 60% contained now. And that's 10 days or 10 days, yeah, about 10 days into this. Any other questions?
All right. Thanks for the update, Chris.
My pleasure.
Let's see. All right. So before we get started with Homebrew contest, do we have any other updates or any announcements from anybody?
Oh, this is Chris again. I do have a little show and tell. I have it sitting right here. If you can see, this is a GPS antenna we had at the site. We have a GPS receiver that is used on the 147.195 transmitter. It's accurate to less than 1 cycle. And as you can see, it has an end connector on it. It's a active antenna, and it melted. It's made by Lucent, but it's pretty rugged because, let me open it up here. There's the little antenna inside, and it's still all intact. Really, all I need is a new dome. Anyway, share that with the group. Thank you.
Thanks.
Yeah, I have the video here that Chris sent. If you want, I can share it to everyone so you can take a look. It's a little short video of the fire.
Sure. Okay.
Okay, let me see if I can do this here. Okay. Okay, let me go ahead and play this. There's no sound on this. Maybe Chris can explain this.
Well, it has captions on. It's pretty self-explanatory. It's just a little before 11 o'clock, no wind, as they say. And this is 11:20 now. He's down at the gate trying to get out. Now they speeded up the video. That's why his light's flashing rapidly, but you can see the glow of the flames starting to come up. And he's heading southbound to Gates Canyon Road. And this is about 10 minutes later. There's two sites right across where the flames are flashing that you'll see at the end of the clip. And that's blowing southbound, so the fire came from behind the camera. And about this point, the power will probably go out and they have no more video. But you can see the firestorm. That's how it was going up and down the ridge. And this is like site 7 of 30. And so they start at number 1 at the north end over 2 miles, and we're down at 27 at the far south end of the ridge. And there you can see how it's smoldering. Thank you,
Okay.
Carol.
You're welcome.
You're muted, Kevin.
That was no good. All right. All right, let me start again. So can you hear me now?
Yes.
Yes.
Yay, there we go. All right, so we've got a number of judging criteria that we're going to be looking at for each of the entries, and the judges are going to award 5 points in each of these categories. So we're going to be looking at, does the project meet its objectives, the quality of the construction, the originality of the project, the quality of your presentation, whether it can be built with available off-the-shelf parts, any creative repurposing of the parts, and whether the project is inspirational. And then we'll total up the points for a maximum 35. And once we've seen all the entries, we'll go off and compare notes, and then we'll come back and we'll award the winners. Let me just see over here. Okay, so far on our list, we've got Dave, Ken, Marty, Tom, Gert, and Bob. Are there anyone else who wants to take a walk on, has got a project they want to present?
Actually, I do too. I have one that actually I just finished today.
Okay. All right, let's add you on the list here. So that's Bob.
I'll go ahead and I'll add it in.
And what's your call sign, Bob?
K6GCN.
CN. Okay, on the list. All right. And any more?
What year were you first licensed then, Bob?
What year was I first licensed?
Yes.
Oh my God. 1958.
I see. And what's the name of your project?
This is a power supply for a VFO, for an analog boat anchor VFO.
Okay, thank you.
All right, sounds good. And any other entries? All right, okay. Well, Phil, Carol, myself are going to be the judges, and we can probably do about, since the group's small, we can probably do like 5 or 10 minutes each, depending how long you'll need on your projects. I've got some photos to share from some of the entries. So depending like whether you've got your own slides, you can present that way, or I've got some photos to share as well for a couple of the people. All right, so we want to get started with. These are in no particular order, but Dave, do you want to start with yours first? I think I've got a couple of photos for you, right? Is Dave still on? I think he was on earlier.
Yeah, I had it muted.
There we go. All right, let me bring up your pictures as well. Hold on. Let's see. Let's see. There you go. All right, so do you want to tell us about your project?
Well, I've done a solar control station that I've made up. I've taken another project that I had and cannibalized some of it for parts, and some are new parts. If you can put that first slide up.
Let's see. Okay, hold on. Here we go.
There we go.
Okay.
That's the control station. On the top, I've got a meter that reads 110 volts out of the inverter. On the left is the battery voltage and current that I'm drawing. And on the left is the solar voltage and current that I'm drawing. The two switches in the center, the one on the left disconnects the solar panel input if I need it disconnected, and the one on the right disconnects the battery through the relay on the backside on the bottom. We'll see that in another picture. And then I've got the a 30 amp solar controller in the middle there, the big box, and on the bottom, on the right hand side, is a low voltage disconnect. When the voltage drops below 11.7 volts, it closes a little or opens a little relay inside, which opens controls the solenoid on the backside and disconnects the battery from the whole circuit. And twice it's happened, the batteries didn't have enough charge, and in the middle of the program, I heard a click and we were in the dark. The solar controller on the bottom is a 600 watt sine wave inverter, and I run my TV and a fan and a light off of that so I can watch TV at night, and if SMUD happens to go down, well, I can still watch TV, or what's left of TV if all the other stations have gone down. On the very bottom of the picture below the board there, you can see the solar input and battery input coming into the bottom backside of the board. Can you go to the next one? Well, that's a little bitty view of it. There. Well.
Not sure if I can.
The
There you go.
there we go. That's the backside of the control panel. On the very bottom, you can see the solenoid. It's a 150 amp continuous duty solenoid that all the battery voltage goes through. The red plug on the right-hand side and the blue plug on the left-hand side both go down through the slot in the bottom of the board and hang down below the board. In the middle upper right, there's two little black boxes there, down there. That's where the plus and minus solar voltage comes in. Those are the little cube 30 amp relays. I put those in, plus goes to one and the minus goes to the other. And they're controlled by that switch on the front panel. And then above that are the voltmeter and amp meters for both the solar, and then the very top meter is the AC voltage. Go to the next one.
Okay.
This third slide, this is the box outside where I have my batteries sitting. I bought 2 Trojan TO105 plus batteries to put in there. They're rated at 225 amp hours, but they're both 6-volt batteries. So I've got a total of 225 amp hours to run the whole circuit. The white PVC pipe on the left matches one on the other side. And I put in there and covered with screen wire to keep the elephants and tigers from getting in there. And then out of the box, cut the red and black wire, go up and through the PVC through into the house, and the controller is sitting right above that inside. The other red and black wire coming out of the tube that has the blue connector on it goes up to the, I have 3 100-watt solar panels up on that I finally got up on the roof. I had to have help putting those up on the roof. Mama got very upset when I tried to get up on the roof, and I got partway up there and I decided that Mama was right and came back down and finally got somebody to help put them up on the panels up on the roof. I'd been running with 2 of them on a laying out on the ground, and they were just shy of maintaining the system. If we didn't have a lot of sun for a couple days, I'd have to put hook a charger up to the system to keep the whole system running. But this whole system powers a 32-inch flat screen TV and runs a fan and a little 10-watt LED light bulb. And with three panels on it now, it seems to maintain itself for the whole evening. We start watching 4 or 5 o'clock in the afternoon, and I go to bed about 12:30, 1 o'clock in the morning, and the system is still cranking away, providing power for the TV and the night light. So, so far it seems to be working just fine now that I've got the 3rd panel on the whole system, and hopefully it'll keep working for a long time. So that's the end, I guess.
All right, sounds good. Thanks, Dave. Any questions for Dave?
Yeah, I got some questions. This is David. I assume you have 2 6-volt cells, so that's it's for a 12-volt system.
Correct.
Okay. Do you use, you said 3 100-watt panels. Did you buy new ones, or did you able to find used ones?
I bought 2 of these panels 3 years ago, I guess it was, and I've used them in a portable solar system. I had it out at field day 2 different years, and I bought a 3rd panel to put with this system so that I have the 3 panels.
So are they new or used?
They were all new when I bought them, but 2 of them are about 3 years old, and 1 was new this summer.
Okay. Do you on your inverter, do you have it so that it runs all the time, or does it when there's no load on it, does it shut down?
It runs all the time. it does have a switch on it that at nighttime when I go to bed, I flip the switch off so that it doesn't put a load on the batteries all
Yeah.
night long.
Well, that's good. Okay, okay. Well, that's all I had. Thanks.
Thank you. Any more questions for Dave?
Yeah, I have one. Dave, you said you had a low voltage dropout relay on there. How does that work?
When the voltage comes down below a set point, there's a little 10 amp relay on the circuit board that the circuit de-energizes and it opens up, and it's controlling the big solenoid on the backside of the panel. And then as the voltage comes back up, it has to get above, I think it's set at 12.4 volts before it will energize again, so you don't have it toggling back and forth on and off. It's a circuit I found on eBay, or not eBay, but on Amazon, and bought and put inside that little black box that was there.
Okay, at some point in time, I'd like to find out more about that because I want to do the same thing on my trailer.
I'll see if I can find the site that I bought it from, and I'll send you the link to it.
Okay, very good. Thank you. That's all.
All right, sounds good. Any more questions? All right, we can move on. Any questions from the judges?
No.
A whole bunch of people. All right.
And that was the first one that didn't.
Let's move on to Ken.
All right, I'm here. I'm going to try doing screen sharing from here.
Okay.
Whoa. All right.
Ooh.
Okay.
The window?
Okay. Back in March, I went out and bought one of the Mastwerx push-up antennas. It had some features I liked, but I neglected to look at the very top of it, which has a thread and then a ring. It's very hard to try and mount anything. The thread is intended for a buddy pole, and that's what the whole thing is aimed at using it with, which I didn't realize until after I got it. And to try and mount it down here is hard because this is the cross-section shape of it. It's not conducive to clamping on with an antenna. Now, I came up with several ridiculous ideas and then discarded them and finally settled for this. The thread is a 1/2-inch pipe thread. So I got a 1/2-inch pipe coupling and then a 4-inch long 1/2-inch pipe nipple, screwed them together and onto the mast. And as you can see, I can then clamp to the pipe, and it's worked fairly well the few times I've used it. Now, if I have a larger mast, this is for a YP3, it has a larger U-bolt clamp. So I got a 1/2-inch to 1-inch adapter, and then another 4-inch long pipe nipple, screwed it in, and then the YP3 mast fits on it very well, and it works. And then here it is set up, used during field day in my backyard, and that's it.
Very good. All right. Any questions for Ken?
What kind of antenna is that that's on it right now? The vertical or the horizontal?
Oh, you mean over the left one? Or
No,
on the mast?
the one that's on the mast, yeah.
It is super antenna, older YP1 dipole setup, and I'm using 2 of the elements out of the YP3 for 20 meters.
And do you have that mast guide anywhere?
That for that time, no, I didn't. It does have 2 sets of guy ropes to go with it.
Mm-hmm.
But there wasn't any wind, so I just said the heck with it and pushed it up.
And how high is it?
That's about 20 feet. I didn't have it all the way up. It'll go to 23 feet.
Thank you.
There are 2 other sizes that they make. One's shorter and one taller.
How stable is it, Ken, without any guy ropes?
Not too bad. Now, if there was any strong wind, I would definitely want guy ropes on it, but
okay.
Without guy ropes, it was fine.
Okay. All right, thank you. Any more questions? All right, let's see. Next up, we have Marty. Let's see. Marty, are you on?
Yeah, I'm here. Just okay. I'm muting myself. Okay, I'm going to try to put this photo up. Okay, so hi everybody, I'm Marty, CAM6MFI, and what you're looking at in this photo is my homemade 11-meter antenna. So the vertical part right here is a 102-inch steel whip that would normally be used as a mobile antenna for an 11-meter radio. And to that, I've added 2 counterpoises, also 102 inches, that go down each eave of my house. So the unique thing about this antenna, it's an 11-meter antenna, and I don't own an 11-meter radio. But that wasn't the goal. The goal here was twofold. One is I really wanted to participate in the Wednesday night 10-meter nets for River City ARCS. Second goal, though, was I just kind of got a really old MFJ manual tuner. So I figured, wow, I'll try it on this. I see if I can tune an 11-meter antenna to work on a 10-meter band. And it was a huge failure. I mean, there's something major wrong with a really old tuner. So you get what you pay for. So I kind of set it aside for a while. So I still want to participate in the 10-meter net, but now I have to prepare for field day, and I have no other high-frequency antenna. So I literally throw a random length long wire across my roof. I connect it to an run it down, coax into my radio, and voila, it works on multiple bands. On 2 bands, I have a 1-to-1 ratio, and on 2 other bands, using the auto tuner, on 2 other bands, I have 1.5, and that's where my 10-meter radio is. So I'm thinking, wow, this is pretty good. I have 10-meter now. I can participate in the nets, and I tried a few times, and sometimes it was kind of a hit and miss. In being it's a horizontal antenna, and it's just literally draped across a roof. It would work on some nights, and some nights it wouldn't. And then come field day, I suffered a catastrophic failure of my brand new cable that went from my radio to my brand new auto tuner. So field day was a big bust. So I had to kind of start from scratch. So pretty soon though, it was time to try to participate in another Wednesday night 10-meter net. So I said, what the heck? What I'm going to try to do is I'm going to just run that antenna directly to my radio. It's an 11-meter antenna, and I'm plugging it directly into the back of my radio. And when I key it up, 1-to-1 SWR. I really can't explain it. I don't know. I figured everything was long, and I'd be able to trim it down to make it work. But I didn't have to do any adjustments. Everything's 102 inches. So now I have the long wire antenna. So on nights where it's horizontally, antennas are working better, I have that. I have a vertical antenna on other nights when that seems to work better. And my plans for this, I have a couple other plans. I was thinking about, instead of using the counterpoises going off horizontally, to try a couple of different ones. One, just making a counterpoise that goes straight down. So it's kind of like a vertical dipole. And then I was lucky enough to score some pieces of aluminum tubing from Hank. It's antenna tubing. So I'm thinking about minimally making a ground plane 2-meter antenna, but also trying to make this antenna into a regular ground plane 10-meter antenna. So there you have it, my 11-meter antenna that works really, really well on my 10-meter radio. Questions?
Yeah, questions.
I have one.
Sure.
Can you hear me?
Yeah.
Before you hooked your rig to it, were you able to put an antenna analyzer on it?
No.
No, you just use the auto tuner?
Correct.
These two wires that you have hanging underneath what you call your counterpoise, those are actually radials.
Okay.
Those are a elevated radial, and what you've done is exactly the right thing to do for a ground plane antenna. And so whether it's a wire radial or a tubing radial, they serve the same purpose. I suspect you wouldn't be able to detect any difference in performance either with wire or tubing, but certainly adding additional radials will be helpful. It's very creative.
Thank you. I was thinking, though, that this makes it somewhat directional, and I really didn't want it to be directional. So that's why I was thinking about going full ground plane.
Marty? Let's see. Tom Schiller indicates that you only need 2 radials. So you can get away with just maybe using one on each of your peak there and make it work.
Well, yeah, it's working great right now. I just want to play around with it some more and see if I can't even make it better.
If you add more, it might make it better, but that's the minimum that you would need right there.
Sweet.
Rudy Severns, who's a really famous guy for vertical antennas and that kind of thing, he's kind of fond of 4 as a minimum. Tom uses 2 because when he does his de-expeditions out in the middle of nowhere, it's most convenient for him. But 4 certainly won't hurt. It'll improve it'll lower the feed point impedance slightly and improve the efficiency. So in either event, it sounds to me like you're on the right track.
Yeah, the reason Tom uses 2 is that he does it on the beach. And so the only land is left and right. So that's the idea. I may be behind you.
I have another question, Marty. How many times have you checked into the 10-meter net, and what kind of Q reports have you received on your 10-meter check-ins?
I'll say I was successful 6 out of 8 tries. So a couple of times, I don't know if it's a band or if it was me, I just tried many times and could never get picked up. But that was mostly off my horizontal antenna, my long wire. And then with this one, it's working. Well, it depends. It works really well if the net control is using a vertical antenna. It doesn't work so well if the net control is using a horizontal antenna.
Okay. Have you made any other contacts on 10 meters besides our net?
I don't remember. I guess not.
Yeah, there's not much activity there this part of the solar cycle. But we may be getting a little bit more propagation maybe right around this the equinox. You never know. That's coming up. That usually picks up some propagation. But very good. Thank you on the presentation.
Thanks.
How much power are you using, Marty, at the point where someone else could hear you when you got checked in?
Like if Carol's net control and she's on a vertical, I get Q5s. I'm on my horizontal. Sometimes I get Q4s, Q3s, and sometimes I'm not read at all.
Are you running 100 watts though, or less?
100 watts, yes.
Okay. All right, cool. Any other questions for Marty? All right, thank you. Let's see. Next up, we have Tom.
All right, thanks, Kevin. my thoughts were to come up with a design of antenna that I've not seen before. And the idea was, if you could make a plasma out of air, a plasma is a conductor. And if you could do that, and you're in an HOA, you could say, have a laser beam pointing up in the sky as long as you'd like it to be. And if you could somewhere latch on to the conductor, you would have an awesome antenna. And so that was my first thought, wow, that'd be really cool, a virtual antenna. And then I was researching it some and found that in order to make an antenna like that that could actually take the nitrogen in the air and turn it into a plasma, you would also need protective goggles, and everybody else around you would. And it was extremely dangerous. I found a website where this guy was doing something very similar. And then he actually switched and created what he called a nitrogen laser. So that's part of my presentation. Let's get started and see if it's going to work. Let me first bring up my web browser and then see if I don't cover up my screen, which I did, and then share it. There. All right, is that seeable?
Yes.
Yep, that's good.
All right, so this is a blog that I wrote it up in. So the topic is a plasma antenna playing with new technology antenna. So as I said, I began reading about plasma antennas last year with the idea of using a laser. And I thought, wow, if in an HOA, that would be easy. All I need is something like a lightsaber. So if I'm reading further through the top here, I found that there was a website on YouTube, a guy named Styro Pyro. He's a guy that plays with all kinds of lasers that are probably illegal in the United States. He gets them from China and then soups them up. And the best he could do for a nitrogen laser was to do a pulse, because for some reason he could not have a continuous laser. And I left a link for that, and this will be in the notes when we're done, to find out about this particular guy. He's an interesting, I guess, a student in college, but the Styro Pyro part, the pyro part I get once you watch his videos. And that discouraged me a little bit. And then, because I thought lightsaber antenna, not lightsaber fight Jedis. So I continued research on virtual antennas, and I came across, some other areas of use. It could be used in small areas, like in small properties. The plasma antenna can possibly use in HOAs, like I just reviewed earlier. And then there's military uses, because since they're virtual, there's no metal. So I guess they're radar sort of invisible. And I thought it would have been a good idea, but it didn't pan out because technology of lasers is not there, and it's dangerous to shoot something in the sky like that. So then I read about another way, using a contained gas, like a fluorescent tube. And by turning on the light, by powering the fluorescent tube, it becomes a plasma inside the tube. And so I thought I would then experiment and try and make it a 2-meter antenna and see how well it worked. And then I'd read about a guy that was trying to sell a Wi-Fi extender. Basically, they would take a sleeve and wrap it around one single fluorescent bulb, and that would act as a larger antenna for extending your Wi-Fi from one room to the other. And it was thought that in classrooms or whatnot, there are always fluorescent bulbs lighting the area. You could use that as a Wi-Fi extender. But my idea was, well, those tubes are 4 feet long, a little bit longer than Wi-Fi, which is, 2.7 gigahertz or something like that. 2 meters is roughly a quarter wave of 2 meters is small, like 3 feet. So I thought, well, 4 feet, a longer antenna is always good if you're from HF point of view. So I had a little picture of his idea for the Wi-Fi, and that's what's right here on the left. It's a single tube. And then I said, well, how do I create a sleeve around the outside of the bulb so it interacts with the plasma inside to become an antenna? And I kind of believed it would work because I actually have a beam at home, It's a high gain EXP14. And let me make it a little bit larger if I can. I don't know, is that gonna, let's see. It's bringing up another screen, so that's probably not going to work. So let's skip that. That little picture there, you see the driver has a beam in front of it and a beam in back of it really close together. And that's about the middle of the antenna. The driver is the active part of the antenna, and the front part and back part are extensions used for 10 meters. So the driver itself is good for a range of about a half a megahertz. So it handles the 28 to 28.5 frequency range. And then by giving smaller pieces in front and back, you can handle the entire bandwidth, you know, from 28.5 to 29. And so by parasitically, they're not connected, they're just close together, they act as an antenna. So the idea of getting close to something that's conductive is a good antenna. And it's already been proven by High Gain. They actually patented what they call a 10 meter sleeve antenna, which is used for this particular 3 beam, 3 element beam. So then using somebody else's picture, which is very tiny, unfortunately. I would bring up another image, but I don't think it would follow. But essentially there's a power, that little teeny little image there is a tube, the fluorescent tube powered on either end. And on the very bottom is a little metal sleeve, which is attached to a radio. And that's the idea of how you would do it. So my first attempt was, how do I make a sleeve for 2 meters? And so my thoughts were, I would use a 4-foot fluorescent tube. Initially, I got the T12s, which are big, fat tubes, roughly about 1.5 inches in diameter. And I got them from Home Depot, which is interesting in that fluorescent tubes are kind of going away. I'm sorry, I got it from Amy's. And so of the big shop lights that they have now, a lot of them are LEDs. So finding a large tube fluorescent bulb, I got the last one, and it turned out that it didn't work. So I had to return it. And so I returned it for another fluorescent bulb, which were the T8s. They're a little skinnier diameter, about 1 inch. And so after a couple weeks of failing with that, I got the next one to work. And that's not good. Trap. Carol, I sent you an image. You may have to bail me out here. Unless I can get closer to my source. Hang on a second. Let me move.
Okay, you sent me an image?
I sent you a PDF. Let me move into a different room that's closer to the Wi-Fi. And
Yeah, I've got the, that was emailed, yeah.
Yeah. So you may have to back me up if I don't get my website backed up.
I did forward that over to Kevin. Kevin, you've got it too.
Oh, let me take a look. Hold on.
While we wait, if you need, I have several fluorescent light bulbs in my garage that I have no use for.
Well, the thing was, I needed a light fixture as well. I didn't have it, so I figured, other than they're already hanging in the garage, so I bought the only one they had left, and then had to return it and got a different one, and ended up getting some success with it. Fortunately, my browser is not going to cooperate. Interesting. All right, let me unshare and let's go with what I sent you, Kevin, if you have it.
Yep. All right. Hold on. Let me
All right.
bring that up. Hold on. Let's see.
I do have that PDF on another computer, just not this one. So it's not handy.
I just sent it to you about half an hour ago, Kevin.
Okay, I got it. Let's see. Share screen. Okay.
All right, so I was scroll up a bit.
What's this?
Okay, I'd gotten past that part.
Okay.
All right, so the hookup, my idea was to make a sleeve, and the sleeve I thought was to get a 19.3 inch sleeve to wrap around the bulb. And then I would take a BNC connector to my radio, which I used originally for those handheld field picnic day antennas for searching for beacons. So I had a BNC connector, and then I used a BNC probe basically from an oscilloscope. So I hooked the red lead to a sleeve that was around the bulb, using originally we'll scroll a little farther. All right, so I have a hose clamp around the bulb here, and that was my original thought for creating a sleeve. So I took the red lead and connected to that, and the black lead, I ended up dangling a 19.3 inch for the other end of the dipole, and thought, okay, I have an antenna. All I have to do is turn this on and light it up. And what I found was that by taking the black lead, the little extra 19.3 inch wire that was just dangling as the other end of the dipole, taking that off, it actually worked better. So I ended up just leaving the red lead attached to the fluorescent tube. And the fluorescent tube acts as an extension. However, when I first tried this particular hose clamp, it didn't work. So I thought, okay, let's get a little smarter and let's make a bigger sleeve out of wire. So I ended up using a red 24 gauge hookup wire and wrapped it around. And that's the next slide that's a little farther down here. And it ended up looking like that. And this, I have it inside the light fixture, and the other bulb I do not have it at this moment. So I didn't have any idea of how wide I should make it. I just kind of wrapped it around, and then I put some tape on it and said, there I go. And then I took I bared one end of it off and hooked up my probe to it, and then gave it a try. And so the little farther down is the dangling. I think you can click that, Kevin, and it'll actually bring up any of them. The one above it. No, it won't do it, huh? It'll take it to my website. All right, well, we'll work from here then. Just making bigger images.
Yeah, I can zoom in, I think.
All right, so I made it in a vertical configuration, and then I lit it up, and then I tried connecting into our repeater, and was sort of successful. And then I tried checking in Wednesday into our net last week, and was successful. I don't know how well people were hearing me. I did model it a bit, and it does need some matching. It isn't because the bulb is about I don't know, a wavelength and a quarter too long for a quarter. I would prefer a quarter wavelength antenna. This is a wavelength and a quarter in length. So moving down a little farther, skipping stuff, your stuff to read, which will be on the website. So scroll down to the next pictures, and it's a shame these are so small. I modeled it on NEC2, and it has kind of a nice flat, this is horizontally configured, a nice flat, about 16-degree angle coming off, and it has an 11 dB gain on the with using two bulbs. It acts kind of as a beam. So if I have the driver pointed in the direction I'd like to transmit, and the other fluorescent bulb, which is 2 inches away, it acts as a reflector and then gives me a little bit of gain at least in the model. And then it has this weird bump above it because it's an overlay too long antenna. And that actually you can see is more of a vertical configuration than horizontal. So I think this would work best if you mount the bulb vertically. But if you have a shop and it's already mounted horizontally and you just do a wrap like I did in the example, you should get some kind of gain. It's better than just a monopole. That upper blob on the right is basically an 8 dB gain over an isotropic, where the isotropic would be 6 dB essentially. So a couple dB gain. And it goes off at about a 55-degree angle, so way off into nowhere. And then a little farther down is the 3D model. which looks like a blob. But this is the directionality of it. To your right is where the driver is pointed, and it has a backside which is less, like you'd expect, and it has two bumps which are too bad because it's too long. And then a little farther down, you can, using this model, you can actually get an idea of a antenna Cartesian coordinate system, a real and imaginary part, which I wrote down there. This is what I modeled it to be. And then throw it into SimSmith, you can then turn up an idea how to match it. So I ended up using an L-match, which is actually in the mail coming at me. So roughly 23.46 picofarad, which doesn't exist, and a 22.6 nanohenry inductor. But using standards, which are a little farther down here, you can click through it. It'll take you to websites, theoretically. I ended up choosing a 22 picofarad capacitor, which goes from the center pin to ground. And then the inductor, it makes it a little extra length. And that's essentially for about 200 nanohenries is about an inch of 24 gauge wire. So I needed to lengthen my the wire just slightly, so I ended up doing that. And that brings it, in theory, in modeling anyway, until I can actually do this, a 1.3 to 1, which might even be pretty cool. As I said, I was already able to check into the net, but a lot of my power is just not 50 ohms. It's somewhere in the range of 20 ohms roughly currently. Scrolling down a little further. I had some ideas about Tom Ziller. He's got, if you've ever been to Pacificon, he has a flamingo that he uses as an antenna. And I wanted to order a fluorescent flamingo. And my thoughts, this would be a good field day experiment. I have it in, and that's kind of what it looks like. On the left is with it de-energized. On the right, it's lit up. I took one leg and wrapped some wire around it. I only got it yesterday, and have it working. And I'm able to receive the repeater and at least have the repeater answer me. Scrolling down a little further, this is Tom Ziller N6BT's antenna. So this is the idea of competing with him. So here he is, I think, measuring with a quadcopter field measurements of his flamingo antenna. I'm going to call mine 2.0 as well. And then scrolling down further, Tom Ziller says that any antenna works. So he had a 150 watt bulb that he tried out. And he was able to make contacts. And if that lower thing would expand, which probably won't, he basically says that it was part of his illuminator project. And he said if there was an exceptional receiving antenna, they could hear him because he could throw enough power into the 150 watt bulb to transmit, and then he could theoretically receive if they had enough power going back the other way. And then Tom Ziller went a little crazy and ended up using the 3 bulb configuration. And that's this smaller image here, which will be able to expand when you're on the real website. And I thought, Phil, when I saw this, if we're going to do 3 fluorescent flamingos, let's say, you could come up with Phil's idea of having 2 vertical antennas. You could do like 3 phased array flamingos out in the yard, and it would be pretty cool. And I think HOAs would not care because it looks like art. So that's what I've got. My 2.0 I'm going to be working on for the next couple of weeks. When I get all the parts in, I'll have the matching. And you might hear me again on 2 meters when I'm done and see how well the flamingo works. So next time I check into the net, I'll be on the flamingo antenna.
How much power are you using?
I have a 4 watt handy talkie. If you scroll at the top, again, it's the yellow handy talkie was what I am using. And then slowly go through, Kevin.
We're looking for the HT. Oh, this one.
Here it is. Okay. So again, I have an HT that I used a BNC connector on the top instead of an antenna. And then I used right now I'm using a oscilloscope probe to hook it up. My thoughts are that I'm actually getting all the proper BNC connectors and coax, and then in the matching segments. And next time I try, it'll be pretty buttoned up and pretty I might have a follow-up image of what it's supposed to look like. Right now, it's just an experimental stage.
Yeah, I have a question. Also, so you're using for a sleeve is a 19-inch piece of red wire that's coiled around the base of the fluorescent tube.
Right.
Have you tried transmitting with just that sleeve that's coiled like that without the tube in there? Because it looks like it might even work just as a helical antenna, helically wound vertical sort of thing by itself. So I wonder how much of the radiation is coming from that, and how much of your power is actually being consumed by the mercury vapor in the tube that you're exciting there to produce that ionization. That part of your power is being actually absorbed by that tube.
Actually, with the light on, I'm not able to hit the repeater, so it is actually working. I actually, Kevin, if you can unshare, I think I can do video-wise the flamingo for a second. I'm running long though. So let's see. There's the flamingo. Here it is turned on. And I have my handy talkie hooked to it. And if I'll see if I can hit the repeater. Earlier it did. Whiskey 6 Bravo Sierra. All right, well, I heard the repeater respond back. I don't know if I hit it.
So are you
close enough?
How are you coupled there? How are you coupled to the
sleeve?
Yeah.
If it's
okay.
There's the end. It's not very wide. This is also a 19-inch piece, but it's basically covering about an inch.
Yeah, I think it's working more like capacitive coupling there. Yeah.
You know, I can shed some light on that.
Yeah.
Light. Plenty
of First of all, oscilloscope probe, the center conductor is actually a piece of resistance wire. So you put a very long resistor in series with your transmitter to the lamp.
Yeah.
Which kind of complicates your life a little. Secondly, what would really be helpful is if you were able to actually use an antenna analyzer and measure the true impedance of your coupling. That's the way you need to get a proper match, as you probably well know.
Yep, I got one. I did.
But there's another point, and this one I think you'll find ironic. For several years, there's been a company out of Japan that sells a lamp tester. And the lamp tester looks like an HT, and it's got a little telescopic antenna. And when you press the button, it generates RF, and you use that probe to put it next to the lamp, and of course it ionizes the gas. And way back in the days of my youth, I had a buddy that was running a big kilowatt CW station. And on 80 meters, he used to take an 8-foot fluorescent lamp and walk out in his backyard as somebody held the key down. And the lamp would just glow as bright as you could imagine as he's walking around the yard underneath the high voltage point of his dipole antenna. So what you've done is been around a while. It's a very clever way of approaching things. My hat's off to you. It was a very interesting topic, but I think it'd be really illuminating, back to that same point, to see how it measures and adjust your coupling to suit. And of course, you need to get rid of the scope probe because that's not helping the cause. But it's a very creative way of doing things. Congratulations, Tom. Good job.
Yeah, it's experimental. I want to get the probe out of there and actually set it up properly. Then I'll do the matching measurements. Right now, I agree the red probe wire is probably about 3 inches, so it could be acting as an antenna. Throwing me off a little bit, actually.
I don't have any other questions.
Tom, how are you energizing that flamingo?
The light, it comes as a fixture from a company that If you go to Amp & Co., they have a flamingo light among other things. I was thinking about getting a lightning bolt one too, but I didn't get that one. I wanted to match Tom Schiller's.
So that's what, AC 60 cycles? That's energizing that?
No, actually, it's actually a lower voltage because the AC pops into basically a wall wart, and the wall wart plugs into the fixture. Let's see if I can show you. It's probably not going to work well. There's a wall wart, and this is where it's plugged in to AC from here. So it drops the voltage down, I imagine. Or at least steps it up. I haven't read it.
So there's probably some kind of high frequency voltage that's operating that thing. It's ionizing the gas in it.
It doesn't.
And if so, is that interfering with your 2-meter signal?
I can't receive without it energized, but I can transmit without it energized. If you noticed when I transmit, the lower leg actually got brighter. Anyway, it's new to me. I've had it a day, so I haven't messed with the flamingo a lot. I had the shop light a little bit longer. I had it for about 3 weeks. And I do like the idea of having
once the gas is ionized, you've got that conductor. So the fact that it's on makes perfect sense, right?
I think if you had a big 100-watt transmitter, you would probably ionize it just by transmitting.
Yeah, you probably would.
You would.
I have a suspicion that the circuit in the base of that flamingo is probably a little HF oscillator. It's probably working very similar to one of those compact fluorescent bulbs. That it generates some HF, and that's what's operating that bulb.
I think it's a switch mode power supply, Carol.
So I was just wondering if that was interfering with his signal. Maybe it worked better if it were a bulb where the gas was ionized with DC rather than AC, and you can do that with fluorescent light. I've done it before. Phil?
Yes.
Do you remember those 103.5 volt walkie-talkie batteries you used to be able to get from the surplus stores?
Nope.
Yeah, they were used in the old surplus. I forget what the model was. It was a pack radio that they used in the Army. But they were about 1 inch square and about 1 foot long, and they were 103.5 volts. And they would light up a 40-watt fluorescent tube just like AC.
I'm suspicious that it is a DC power supply. I haven't got my voltmeter out to check it.
I think you're going to find it's a switch mode inverter running about 100 kc. If it's anything of current design, that's what it'll be. They're all switch mode.
Anyway, I do like the flamingo, but the fluorescent light was what I wanted to present. This one just came in about the right time. So this is going to be 2.0.
I love the flamingo.
All right.
Very cool. All right. Let's see. On the list, we have Head Gert and Hank as well. Did you have? I think you sent me an email, Gert. Did you have something to present? I don't know if it was you or Hank.
Yeah, I think her microphone quit. She's got that same unit that I had when I was trying to do a presentation a couple of months ago. So I think what's going to happen is she's going to put the images on the screen and I'm going to read the text.
Okay.
Maybe.
Or if you can email them over, I can share them. Whatever works.
Yeah, I can't hear what she's saying. Just go ahead and email them over to Kevin and we can go on to somebody else maybe.
Okay, all right. Do you want to move on to Bob Mix?
I'm here. I've never done this before, really, but I'll try to share the screen. Can you hear me?
Yes.
Yep, you're good.
Okay. Phil and I put on a little do-it-yourself group a while back, and it's been, I don't know, 7, 8 months, something like that. And after that, I got very, very busy. But we discussed, what other kind of projects can we do? And Phil said, well, I really like that tin-ear receiver. And so I downloaded the 46-page manual. I'd heard of the tin-ear receiver. And the circuit is in there. The tin-ear receiver was a kit put together by the American QRP Club. And it's just a receiver for the entire 40-meter band. It has 8 transistors. It has no ICs. It has 3 inductors. The little inductor in the upper left for the antenna. There's a choke down here. And then there's this coil here that's used for the tuning. It's a permeability tuned receiver. The tube there is a soda straw from McDonald's, I think it was. And then you wind wire on it. And there's a brass screw that runs down the middle of that. And as you turn the knob, the screw goes in and out. Now, Phil designed this permeability tuned piece. And then he also designed the circuit board. He did all the work. I just put one of them together. We discussed it back and forth, made some changes, and he got a prototype to work. And then he sent me the Gerber files, and then I went to the JLC PCB site in Hong Kong, uploaded the Gerber files, and had printed circuit boards made. So I sent them $8 with PayPal, and they sent me 5 boards back. And so I put this one together. Phil was very skilled with EagleCAD for designing boards. He'd done many of them before. And for this one, he wanted to try KeyCAD, it's called. I understand that's the proper way to pronounce it. And so this was his first project using KeyCAD. And he's now a big proponent of KeyCAD, thinks it's better than Eagle. I have 3 of these boards left if anybody wants to build a receiver. I'm happy to hand out the boards or mail them since we don't want to socially make contact. I think that's the whole thing about that. I have some other photos. That's one receiver. Are there any questions about that receiver? I'll just move on.
Well, actually, I do. You have a torrid in there with another wire, a thicker wire going through. Is that a transformer you're building on the top?
Yeah, that's the transformer on the antenna.
Okay.
Yeah. You would think it'd be closer to the BNC, but that's what it's for. And there's a pot there to handle the RF gain.
What bands does it receive on?
The entire 40-meter band.
Okay.
Yeah. You have to crank the, the knob quite a bit to move all the way across the band, but it really works. And we hear CW, we hear single sideband.
How about the frame of the tuning circuit, the white box? How was that made?
Well, Phil would have to tell you about that. Phil can make anything. I mean, he has every tool in the world. He can machine things from scratch. That white piece there is made out of plastic, I believe, and then he threaded it nicely. It's a precise piece of equipment. You want to say something, Phil?
Yeah, it's made out of medium density polyethylene, drilled and tapped, and then I milled the housing so that straw fits tightly in it with adequate clearance so that screw can go in and out. And of course, it's tapped on the bottom so that you can mount it to the printed circuit board. And then the knob itself, you have to put a little piece of plastic on the end of that screw so that you can tighten the knob down on it. When I put those together, I chucked them up in the lathe and turned it all nice and smooth. So, I mean, when you run that knob in and out, it's smooth as glass. You think it's a machine tool or something. It worked incredibly well. Very stable too, by the way.
It's really nice. So that brass plunger there is pretty nice and smooth for tuning. It's pretty linear or nice across the band.
It's very linear, and that's just a 632 screw, 632 by 2-inch brass screw from Home Depot.
Nice.
And the straw actually came from Taco Bell.
Okay.
Hey, I grew up, my first job was at McDonald's, and I didn't want to correct anyone, but that's not a McDonald's straw.
What's the best DX you've gotten with it?
You get international broadcast stations with it. It's surprising how sensitive it is.
And it's not overloaded by local AM broadcast stations, is it?
Well, it all depends upon where you live, but of course it can. It's a direct conversion receiver. You can overload it pretty handily. But again, you know, it's the beauty of it is it's that permeability tuned oscillator. I thought that was the most clever thing I'd ever seen.
Yeah, it looks like it's modeled after one of the Collins PTOs.
It's of a similar design, yeah.
What's your material cost there? You know, I know
to build those.
Yeah.
Well, Bob just told you got 5 boards for $8. You get 2 screws or 3 screws from Home Depot for I think it's $2 to buy 2-inch long brass screws. And then the rest of the stuff on that board, you got a couple of jacks, a potentiometer, and a fistful. You probably got another $5 worth of parts, so under $10.
But you need shipping.
That'd cost you another 15.
I know, that's a hard.
Now we order parts from Tata Electronics. They have a warehouse in Colorado, and the shipping's reasonable. I don't remember. It's been, you know, many months since I've actually bought the parts and used this radio.
Nice one. Thank you.
Okay.
Very good. Okay.
If there are no more questions, I'll show you something else. I also recently, where did we go? Oh. I hadn't done anything for several months, and then I saw a circuit for a little WWV receiver, 10 megahertz WWV receiver. So I had the parts here, and I plugged them into a solderless breadboard, and I'll be damned, it worked very nicely with a 10-cent 10 megahertz crystal. There's a 9-cent diode there. I do varactor tuning with it. So there's a pot that comes off to the side there that varies the voltage on the diode to reverse bias it and turn it into a capacitor to tune the 10 megahertz just right. And I'm surprised at how loud it comes in. There's some, I don't know. Anyway, fun thing about it is that WWV is coming out of Fort Collins, Colorado, and it's like 10,000 watts. So it's like the loudest station out there. So it doesn't take much to hear it. And you don't hear much. You hear a tick-tock. Then every minute, there's a gong that goes off as the minute turns over. And there's also some talk where they tell you about weather conditions and so forth. So anyway, that was fun. I was surprised that it went together so easily and it worked right away on the solderless breadboard. So then I went and tried to make a more permanent version. And that's what's going on here. Not wanting to scroll up like it should. Oh, it's just taking its time, I guess. So then I made a more permanent version of it, and that works nicely too. And I'm using a camcorder battery to power it. Got the jacks in there, and here's the pot you can see that I used to tune it. There isn't much to the circuit, but it was fun to do. Quick and easy. And what else? I guess that's all. As I use it at different times of the day and night, in the morning it comes in very loud, and then it's much fainter during the day, and then it's loud again in the afternoon and in the evening. So it's fun to hear propagation changes with a very simple radio.
Question, Bob.
What?
Is it driving a pair of headphones, or do you have it driving an amplifier for a speaker?
There's an IC amplifier, an LM386, and then there's headphones. These are
oh yeah, I see.
2 earplugs over here. Yeah.
Okay.
Yeah.
Did you mention what kind of detector you're using there?
It's using an SA612 mixer.
So it's AM detection?
It's a direct conversion receiver. Yeah, about as simple as you can get.
And you said the potentiometer tunes. How does it tune? Because you got a crystal oscillator there.
It's reverse biased a diode, a 9-cent diode there.
Okay.
And the pot is just changing the voltage on the diode.
It's a series, there's a series capacitor with a crystal. And as you vary the voltage across the varactor, it varies the series capacitance, which slightly shifts the crystal. It's a VXO.
Right. You pull the crystal a bit. Anyway, it works nice, really simple. Total parts were about $5. The circuit board here is a prototyping board that cost 60 cents from China, banggood.com.
So what you're doing is you're tuning that crystal for a 0 beat, essentially, right?
Yeah.
Yeah, because if you have it off, you're going to hear a heterodyne.
Yeah.
Okay.
So it comes in nicely. So.
Oh, what's the antenna that's connected to it?
Oh, I've just got it hooked up. The BNC connects to my regular ham radio antenna.
Okay.
Through a connector to an N-type PL259.
Yeah, you should get together with Tom and try the flamingo antenna.
Yeah. Yeah.
Need something for 2 meters. Or I need a bigger flamingo.
How large do those flamingos come, Tom? Can you get like one that's about like 20 foot high?
This one is 17 inches tall and I don't know, 6-7 inches wide. And if you go all through the directions and wiggles, it comes out to about 19 inches. So it's about right for 2 meters. Surprisingly, I tried to get antennas that were larger than the actual bandwidth I was using. So if I was using something on the HF range, I would need a big honking fluorescent tubes, maybe the 8-footers, and then some coils perhaps. It'd be very illuminating.
Well, yesterday I made a low pass filter for, it passes everything below or 30 meters and below. I haven't tested this yet. I put it together yesterday. And I plan to use it with my Elecraft XG3. The XG3 is an RF signal generator, and you can, it operates on all HF bands at different gain levels. And it's really a transmitter, an HF transmitter, and it's programmable. So you run the utility program, and you can go in there and put in commands so that you can tell it what CW to transmit, CQ with your call sign and everything, and it transmits that out. And then I'm going to be testing the low pass filter with that. I haven't done this yet. I just hooked it up for the picture today.
Cool. Okay. All right.
That's it for me.
Any other questions for Bob?
I have a comment. I started out using a blog website, and my plans when it goes production is to actually make it a blog website for kit building and for do-it-yourself projects. So I'm hoping that when it's ready, maybe by the end of the year, some of these kits that people are working on, they can find it easy to present on a web page and make it public.
It's a cool idea.
That would be fun.
Very nice.
Yeah.
All right. Okay. All right. Do you want to jump back to Gert and Hank? Are you guys ready?
I don't know how to get out of this sucker. Oh, here it is. Stop share. Okay.
There you go.
All
Okay.
right.
There you go.
Thanks, Kevin.
Thanks.
Now you're an expert.
Yeah, right.
All right. Gert and Hank, are you ready? Are you still on, or did you drop? We can see Gert, but we can't hear
Gert's
you.
talking, but there's no audio.
Right.
Gert's trying to talk.
Move on. Okay, move on. All right, let's go on to Bob, K6 GCN. You had a project as well. Do you want to go on to yours?
Okay. This literally was a last minute project. I finished it this afternoon. So I don't have any slides. I don't have any pictures to show you, but I'll use the camera. Some of you may know that I like to do slow speed CW quite a bit. And I like to do it with boat anchor rigs. The old Heathkit DX40s, DX60s running about 50 watts. I get a great deal of enjoyment out of getting those things up and running. And most of the time, well, just to show you here, I mean, I'm sure you've seen these rigs before, but you know, there's a DX60, for example, and there's a DX40. That's typical of the rigs, and I have them behind me. Well, most of the time I like to use crystal control. These little crystals that we remember from our novice days. And these are great. The only problem is that most of the contacts I make, people are using narrow filters nowadays. So if you're 500 cycles off frequency, 500 hertz off frequency, they may not even hear you answering. And so that if I'm trying to call somebody and I happen to be maybe a kilohertz away or 500 hertz away, they won't respond to me. So
Only what I do with this.
That's when it's nice to have a VFO. And of course I have some old Heathkit VFOs here. But the problem with VFOs is, particularly those that still use tubes, is they drift. So the drifting problem is generally caused by heat dissipation within the VFO. If you've ever looked inside one of the Heathkit VFOs, for example, they'll have these huge resistors in there. And the reason they have this resistor is because the VFOs get their power from the transmitter, from an octal socket in the back of the transmitter. Well, that voltage coming out is about 350 volts, but you don't need 350 volts. You only need about 150 volts for the VFO. So what Heathkit did, and other manufacturers, is they put these huge dropping resistors in the VFO. If you put a huge dropping resistor in there that's dropping 200 volts, it's going to generate heat. The heat causes the VFO to drift off frequency, and you're not very well liked by the person that you're talking to on the air. So how do you get rid of that drift? Well, the best way that I found is to, and this is on the internet also, you use an external power supply. So what I built up and just finished today is an external power supply that only puts out, I don't know if you can see, that's what the front of it looks like. Just has a little fuse here, toggle switch on this side, little light that tells you that you have power on. And you look inside and there's, okay, electronics in there. So all this does is take the 150 volts or generate 150 volts DC, which is what I need for the VFO, from the 117 AC. So you might be able to notice there's two transformers in there. So the question is, why are there two transformers? Well, a lot of times we have to work with what we have. And so I found that a single transformer to get me from 117 volts AC up to about 160 volts AC, along with the 6.3 volts AC required for the tube filament in the VFO, they're not easy to find and they tend to be expensive. However, you can take a transformer and go from 117 AC to 6.3 volts AC, and then go back up from 6.3 volts AC to 117 AC with the second transformer. And from that point on, it's very simple electronics to build a power supply. I think I used one diode, two capacitors, a resistor, and of course the external hardware that you see here. And there's a terminal strip on the back for hooking up to the VFO. And it's a great reintroduction to how simple power supplies are and how effective they are. You're basically taking 117 volts AC, and that's RMS, and then the peak voltage coming out, it's about 160, 170 volts peak. So you take a single diode, you rectify that, and then add capacitors to keep the level up to that 160 volts DC, and voila, you've got a very simple 160 volt power supply with very little heat generated. So I did try it, it does work, and I basically took a problem that affects a lot of us with heat generated from a lot of these boat anchors, and you take away what's causing the heat, because you don't need all that extra voltage drop. And that's pretty much my presentation. I just wanted to show it to you. It's something I put together today. And my apologies for not having any flashy visuals for you.
So Bob, I had a Heathkit VFO as well for part of a radio. And they actually had some components inside just for thermal runaway. So as the unit would heat up, it would vary the power either way to try and stabilize it. So it had essentially, I guess, a diode thermocoupled, so that when it was as it's heating up, it it would eventually get to a stable point, but as it was adjusting, it would adjust with this to make it the voltage stable. So
were those add-ons that Heathkit recommended, or
this was post tubes, so this was basically a transistorized version of well, some analog components inside as well, and but they still had to take care of drift even then.
Yeah, there's drift compensating capacitors that are utilized, but I found that if you just get to the source of the problem, which is the heat itself, what can you do to eliminate the heat? And then you create basically a stable environment within the VFO itself. And it's not so much the heat, because the VFO can eventually find stability or find equilibrium at some point if it heats up a little bit. And that's why you want to keep these things on for probably 15, 20 minutes, even an hour before you actually use them. And then they found a stabilizing point. But with continual heat buildup from these components that are dissipating power that you don't need, the heat situation can get just worse and worse. And in fact, one of the VFOs I bought, I saw that the previous owner had actually created a mod where he moved that heat generating resistor and moved it from the bottom of the chassis to the top of the chassis, as far away from all the other components as he could. And that helped somewhat, but not to the extent where an external supply will help.
Bob, did you consider adding voltage regulation?
Oh yeah, I did. In fact, I actually built a power supply that included a voltage regulator, but then I realized the VFO has a voltage regulator already built into it.
Oh.
So I'm using and by the way, that was another thing I discovered. I have an old VF1 VFO, which is the very first VFO that Heathkit ever put out. And that one used a tube, an OA3 voltage regulator, which is a 150 volt regulator. The next generation VFO that Heathkit used was the HG10, and they used an OB3, which is a 108 volt regulator. Well, I guess Heathkit found out that the VFO is going to work just as well at 108 volts as it does at 150, and that's 42 less volts that you have to worry about. So what I did on my old VF1 is I took out the 150 volt regulator, put in the 108 volt regulator, and was able to create a scenario that was even better than I had thought, by minimizing more heat. So these circuits will work with a lot less voltage than they originally were designed, but because Heathkit originally had 350 volts available from their transmitters on the back socket, they said, well, let's just use that to power the VFO. And it was a good idea at the time, but because of that problem, then they would need dropping resistors in the VFO.
Bob, in the later heat kits, the one I'm talking about, which was the HW104, it had two voltage supplies. It had a 12 volt and a 5 volt, just to,
okay.
The VFO was running on 5 volts.
Oh, perfect. Yeah. Yeah, they didn't have that option back in the late 50s.
Hey, Bob, what about the heat from the tubes themselves? Obviously, they're still there, right?
The tube in the VFO?
Yeah.
Yeah. Yeah. The OA2, or excuse me, the OB2 regulator generates very little heat. And the other tube, I think it's a 6AH6, does generate some heat, but it's nowhere near the amount that the dropping resistor generated as far as heat goes. So, which is why you leave the VFO on. At some point, that 6AH6 oscillator tube is going to achieve an equilibrium. And so it doesn't generate a lot of heat, but the heat that is generated does stabilize at some point, and therefore your long-term drift is minimized. I mean, the next step would be obviously solid state everything. Take out that tube and then use a transistorized VFO, but that kind of takes some of the fun out of it too, if you're running all tubes and boat anchors.
Well, the next thing they used was PLL, and they used a varactor diode, much like was described earlier, to
exactly
control the frequency.
Yes.
So
Yes.
that was just a few years later than mine.
But what was amazing to me is as time goes on, how we get used to our new rigs, and we're used to being very precise and dialing in our frequencies and putting in the narrow filters. And if you're operating CW, literally someone can be 100 hertz off and you won't hear them. And this is a scenario that occurs over and over again during contests. But if you go back to what it was like 50 or 60 years ago, where everything is wide open, and a station you call CQ, a station's calling you 3 kilohertz away, or at that time, 3 kilocycles away. And yeah, you would tune down your separate receiver to that station. And that was what it was like as a novice. So I love the boat anchors because it brings back those memories, and it's just fun to get these old rigs up and running. And a lot of times, unless you tell someone you're operating a boat anchor rig, they won't know the difference.
If you remember the specifications for these radios when they originally came out, they would state for frequency stability something like plus or minus 100 hertz over every 30 minutes after warm up.
Exactly.
Which was very standard back then, but nowadays, if you drift that much, people will notice it right away.
If any of you are interested in Heathkit boat anchors, by the way, this is the greatest book ever. This author, Chuck Penson, came out with a book where he describes every amateur Heathkit device. He describes it in detail, the pros and cons, and it's a wonderful book to have on your bookshelf. Thank you. Thank you, Kevin.
Okay. Any questions for Bob? All right. Let's go see Gert and Hank. Did you get your audio working? I got your photos, Gert. If you want me to share, you've got your audio working.
Okay.
There we go.
Okay. Do the pics. Yeah, something's going on with the audio on my computer. My granddaughter used it the other day, and I think she put something on it that made it not work the way I expected. It's sidelined the audio. So anyway, okay.
Can you see the picture?
What's the name of this presentation?
No, it's, anyway, yeah, we have been riding on our motorcycle to go to various trips, and we decided it'd be nice to keep track of where we were going. So we got a Yaesu FTM 400DR dual band APRS radio to put on the bike. And you can see the unit in the top box, and in the front you can see the face panel. And it's really nice. We have Senna's mounted on our headsets, and we ordered it with the Bluetooth feature, so it allows us to use the Vox on the headsets on our helmets to talk on the radio if we need to. But Kevin, move to the next picture, please. There you go. When we got it, as you can see, the part in the middle with the knobs, that's what came with it, but there's no way anybody who's ever used the GPS knows what getting light on the screen does. You might as well not have it. So we went to Tap Plastic and got plastic materials and built the shroud. And if you will do the next pic, please. There you go. And we had to machine it and so on so that it would mount up. We got a ram mount and made it possible to mount it onto the bike. And it worked well. The plastic is cheap because when you're using smaller pieces like that, you can get them for like 50 cents a piece and sometimes free because they have a bargain bin at Tap Plastic, especially if you're using, you know, thin stuff. And ABS is real nice to work with because you can weld it with, well, you can glue it or you can weld it with acetone. So it was nice to work with. And it only cost us a couple of bucks to build it up, besides getting the ram mount. Anyway, we can move on to the next one. Next pick. Oh, that went the other way. Yes, and that's a close-up of the radio unit that sits in the top box. And as you can see, we've set it up with the Anderson power pole connectivity so that it's easy to remove to service or use elsewhere.
Yeah, I want to say something here. On the back of that APRS radio is a small fan. Since this trunk is closed normally when we're riding, I bought another fan unit that the radio bolts to. It's underneath it. It also runs off of 12 volts, so it stays plenty cool. I haven't had any overheating problems at all. Okay.
Okay, next pick. There we go. Well, we were so satisfied with how well the plastic was for making the shroud and so on that we went back to Tap Plastic and got some more of their material the next time we needed to make an enclosure. Anybody who's ever gone out shopping for project boxes knows that they're exorbitantly priced and very seldom actually fit what you're doing. And we decided to take measurements and make our own. And so we put solar panels on our patio roof to power his batteries that are under the bench. And of course you need fuses, you need some way to monitor them. And so we've got a meter for checking the voltage. Yeah. Just check the voltage and amperage and so on. And the red digits are the solar controller that came with the panels. And then we mounted a fuse panel because we have various things we attach to this besides fusing the incoming voltage. And we just happen to have a Micronta, an old Radio Shack 12-volt radio that we never installed in a car. We thought, why not? Works just fine. So we
radio clock.
And it just happens to be a clock radio or a clock, yeah.
Okay.
An alarm clock. Never mind, not a radio. Anyway, when you're on the radio, you're supposed to keep a log, and it's a nice, handy way to have the time readily available. And we left room to add other things because sometimes you just need to do that. Okay, and we can move on. I think there's another picture that shows it straight on, so it looks kind of nice. It's a nicer picture of it.
There you go. Yep.
Yeah, it's a nice straight on picture of it on that. But you can see if we were using it, the panel with the Andersons and so on are such that you can even close them up and protect them if you're using them in a mobile setting. So the Anderson makes some nice stuff. Okay, and next. And so we modified a travel trailer, a cargo trailer to make it a travel trailer. It still looks like a cargo trailer on the outside, but on the inside it's paneled, has nice flooring, cedar ceiling, a whole galley, a bathroom. It's ready to go. But we wanted to take our radio with us, and so we still had to have a power unit and a place to hook up the antennas. And so again, we found some plywood and availed ourselves of another piece of Tap Plastic and put together a panel. And of course you can see there's the connectors on the face of it. And if you go to the next picture, did I We put a 4x4 box up on the side there and brought the antennas externally, and we can put a 2-meter or his screwdriver antenna on there and use the radio when we're mobile. Or
there's 2 SO239s on there. One's for the screwdriver antenna and the other one's for a portable antenna. Whatever we want to plug in there, we can cable into that.
Yeah. Anyway, and as you can see that those 2 white brackets ahead of it go all the way across the roof. That's the rack that has 300-watt solar panels on it that keep the batteries charged up. There's 2, what are they, 75?
No, 105 amp hour.
205 amp hour deep cycle batteries are in a box on the top. And the whole thing is it's closed up, so I didn't take a picture of it, but it has an inverter and all of the controls we built into the trailer as part of the solar setup. It was going to be its own show and tell, but I decided this was enough for this time around. Anyway, any questions? Does anybody have any questions?
No questions?
Great presentation. Thank you.
Thank you. All right. Thanks, guys. All right. Let's take 5 minutes just so judges can compare scores, and then we'll come back in about 5 minutes. Say like 9:35.
Kevin? It's Neil. We'll leave it's getting very late. We'll leave our conversation on the other subject for another day.
Okay, cool. All right. Yeah. I need to go to bed after this.
Yeah. Give me a call when you have a chance.
Well, Kevin, I didn't expect technical difficulties, but I ended up getting them. At least I had a workaround.
That's okay. There's always something, right?
Yeah.
This is David. Since this is a DIY night, I was going to ask Bob Mix if he's still doing your DIY stuff. That I've got a book here that someone might be interested in. It's a, we can see it. Come on, get up there. Anyway, it's the Arduino ham radio book. It's the first one that came out. Anyway, I ended up with a duplicate. I ordered it from Barnes & Noble, and they sent me 2 of them instead of 1. So I don't know if any of your group that does any of your DIY stuff would be interested in it, but it's again, it's an Arduino for ham radio.
I don't know if anybody would want it or not. We aren't having meetings. We haven't for, I don't know, 7 months. So, but anybody speak up if you want it. That'd be great.
I'm interested in what Arduino projects you want to build.
Oh well, there's all kinds of stuff. This is the first book on the when they had the virtual QSO. Glenn Popeil gave a demonstration or give a talk on Arduino for ham radio, and he had created 2 books. And anyway, I ended up with when I ordered the books, ARRL doesn't have any more, so I ended up calling Barnes & Noble and getting it. And like I said, they sent me 2 of them instead of 1. So I have both books, but anyway, just wondering if there might be someone interested in doing it. There's tons of things that the one that I'm going to build out of it is they have a lightning arrestor or a lightning sensor. And I ordered the parts for it, and they haven't shown up yet. So anyway, there's a lot of interesting things there if someone's interested.
David. This is Bob Mix. Jack Purdom writes books like this. He's coming out with a brand new one, and it'll be published by the ARRL. I don't think the date has been announced yet, but it's going to be soon. And it's just jam-packed with more modern projects.
Yeah.
With projects.
The book I have here has Jack Purdom and Dennis Kidder as the two of the authors.
Yeah, they work together on a lot of projects.
I've not done anything with them though. They're interesting. I mean, they're computer projects in a sense, but a very simple computer.
Yeah, microprocessor. Yeah, they're pretty cool. So, anyway, I dink around with a lot of those things. So, anyway, so if you got someone out there that might be interested, just let me.
We're still comparing notes. Give us 1 or 2 more minutes. We're almost there.
Should we put that up on the website for anybody that would be interested in that book? I know that we have a section for sale, but we could put that in as for shipping.
Yeah, you know, it doesn't really matter. Just that I don't need 2 of them. Who do I talk to? Talk to Phil?
I think if you can send it to contact@n6na.org, and Carol will get it, and we'll figure out how to get it out to everybody, that it's available for anybody's use if they'd like it.
Yeah, okay. Sounds good. I'll do that.
Okay.
So we're talking about this new Arduino stuff, and we talk about both anchors. I have a question for everybody. I'm cleaning up things, and I found out lots of pictures, and I found out a small square reel-to-reel old tape. Does anybody knows of the existence of something that can play that nowadays? I have no idea what's in it. I just hate to throw it away until I find out.
I used to have a car with an 8-track.
Hey, Neil, I've got a reel-to-reel tape recorder, so it should play it.
I tell you what, I can send it to you. I want to try to digitize it, you know, but
Sure.
Anyway, you know, I've been digitizing all kinds of old VHS tapes of family things, and in the middle I found this. So yeah, we'll talk about. I have only 3 more Morse code classes. Then I'll be back on the Wednesdays nets again. We'll chat.
Okay, so your tape is a 1/4-inch audio tape, correct?
That's correct.
Okay, yeah.
We'll chat. Thank you.
Yeah, I've got 2 machines, and at least one of them should be still working. I haven't pulled them out of storage in a couple of years, but I'll check them out, and it shouldn't be a problem. Glad to do it.
And eventually I will want to talk to you about that slow Morse code coming just out of the class. I probably will need a lot of practice.
Oh, well, if I mentioned this to somebody else last week. There's a group called the SKCC, which is a Straight Key Century Club, that I'm a member of.
I hear them all the time on the radio in the mornings. Yeah.
Oh, okay. Yeah. So.
You lost your audio. I lost your audio, Bob.
Oh, he's trying to do it in CW now.
Yeah, let's switch to CW.
Okay, I think I got it back.
Q0, there you go.
Okay. So what insignificant thing was I saying before I got cut off?
You're talking about the SKCC. I listened.
Oh, yeah.
I'm just trying to talk a little bit, give the judge the time to confabulate.
Exactly. All right. Well, we'll turn it back to, I guess, Carol, or whoever's going to do or Kevin, who's going to have the announcements. Go ahead.
I think we're still comparing notes in the chat room.
Okay.
Phil, Carol, do you think we're ready?
Yeah, I think so.
Okay.
I think so.
Who wants to announce? Does one of you want to announce? Carol?
Okay.
Yeah, Carol's got the big screen. I think she ought to go for it.
There you go.
Okay, sure. We can actually share this screen and show the numbers if that's okay. You want to do that?
Sure.
Yeah.
Okay, let's do that. Share screen. Very close. There you go. First place is Bob Mix with the Ear receiver for a total of 87 points. Second place is Gert, KK6ZGA for the motorcycle mobile rig. And our novice entry is going to be Marty, KF6MFI with the 10-meter vertical antenna. Congratulations to all.
Great presentation from everybody.
Thanks, Carl. Yeah, congratulations, everyone. There were some really interesting projects. So we'll reach out to you guys with, I guess we're going to do gift vouchers. I think that's what we arranged. I can't remember. But we'll reach out to you guys and confirm like how we're going to get the prizes to you.
Well, we've got kind of an interesting dilemma here. In years past, of course, we had actual physical meetings. We handed out cash. Cash is a little hard to do these days without physical contact. So there's a couple of things we could do. I could actually go get some cash and put cash in the mail, which frankly is not a very good idea. Or we can mail checks. And I don't know that that would be something that people would object to. Still money.
What's a check?
You send Bitcoin.
Yeah. For whatever.
Warren Buffett doesn't like Bitcoin.
You can't just Venmo it?
Or PayPal or something.
PayPal, yeah. Would you guys want to let us know how you'd prefer to receive your cash?
Well, he's going to send the checks to me to sign anyway, so I have no problem with the check. It'll just land on my desk. And then it's only 2 more. So how hard is it to send?
Well, hey, Bob Mix, would you object to receiving a check?
I don't really want a check. I have too much money as it is, so I'd rather donate it to the club.
Okay.
There we go.
I think we need.
Well, congratulations on your 10-year. Marty, how about you? Do you object to a check?
Yeah, I'm afraid so.
You object?
I think you guys can just keep the 20. But thank you.
It's $40.
Hey, I'll just use it on something, Vice or something.
Yeah.
Not the club keep it. You guys can spend it better than I can. Thank you, though. I appreciate it.
Tom, I think you need to order more hats or something.
Yeah, but then mailing it is a problem still, but at least it isn't money.
Hand out flamingos. Yeah.
Maybe, yeah, little trophies perhaps.
Or we can keep it in the kitty and we can order some stuff for the next club meeting. Like when we first get together for the first in-person meeting, maybe we can use it to order some extra door prizes or something.
One thing I want to say about this is I would really like to see more of our new hams participate. I don't know how we can promote that any better. Because frankly, the only new guy we really had this time, and he's not new, is Marty. I mean, he's been licensed for a couple of years. So,
yeah.
Maybe there's some thought we can put into attracting some new player participation.
Yeah.
These were really great entries, by the way. I mean, plasma antenna, I love that idea. I like the flamingo even better.
The
And in
fluorescent.
my HOA area, you know, to stack 3 of them in a row and tell the neighbors it's non-antenna. I mean, think of the bragging rights that gives you.
Well, I thought I had you in mind for that last idea.
Oh, I appreciate it.
Put them on your front lawn.
Right.
Neil, show Gert the envelope.
The envelope.
One idea.
Oh, that's perfect. Oh, that's perfect.
Hey, Tom.
Third time was a charm.
That is
good.
What?
That is so absurd.
1, 2, 3, 4, 5, 6, 7, 8, 9 stamps for one little pen.
Well, Sylvia was stubborn. It was going to get to you hook or by crook.
Tell you what, next time you let me know, I'll come and pick it up. It'll cost you only 8.
No, you
Well,
can't.
he was going to drive it over, and I said, no, you're not.
Stubbornness has to follow through.
Yeah.
What I will do, thank you so much. What I will do, I'll take the amount of this and we'll donate to the club.
Well, I think that we could do DX engineering gift certificates or something else, which might be in lieu of money. Maybe people will like that. Hopefully people who did get the DX engineering will find a use for it.
There's that. There is that. But you know what? I think right now our repeater fund is probably in need of some refurbishment, eh? And what $837 we've put out of it?
Yeah, and you know, typically we'll go 2 or 3 years without spending a dime. This was kind of exceptional. And you know, the interesting thing about this is while we set aside a certain amount for the repeater fund, if we run into situations, we can certainly earmark money from our general fund for repeater use. There's nothing that prevents us from doing that. We're not hurting for money.
No.
We're stable.
Yeah, there's going to come a time when we can get together, and having cash on hand where we can make it a fun thing is not a bad thing at all.
Yeah.
You know, one of the things I think at some point we may wish to consider is enhancing our ability to set up for field day with some lightweight antenna options. And we should probably take that up as a topic at one of our board meetings. I think we may be in a position to kind of address that issue. I have nothing else unless the boss has something else.
Nothing else, no. Any last minute comments or can we wrap up?
I think we can.
I have one thing here for Tom.
Yes.
For your next antenna, your next plasma antenna. How about that?
Using a tube?
Yeah.
It's a big one. They use it in the rectifier units in the Bell system back in the day.
Does it fluoresce when you power it up?
Blue.
Yeah, pretty blue one.
Well, it isn't very big, so it'll have to be a high frequency antenna.
You need several.
Yeah.
Maybe phased.
All right, folks, I'm going to say good night. Thank you all.
Very good, everybody. Thanks for all the entries. It's really good. Thank you.
Don't forget net tomorrow. Tomorrow's net.
Okay.
All right.
Everybody have a good week.
All right.